analytic function. Theorem, let f of z is equal to u plus iv be analytic in region D, when u and v have the continuous partial derivative up to the second order, then u and v be the harmonic function. So we will see the proof. So let f of z is equal to u of xy plus iv xy be the analytic in some domain D. Then CR equation, ux is equal to u vy is equal to minus vx in D. This is the equation number 1. uxx by addition uxx plus uyy is equal to v of xy minus v of yx. So this is equation number 2. This is 2. So since the function u and v have the continuous partial derivative up to the second order in D, we have v suffix xy equal to v suffix yz. Then the equation 2 gives u suffix xx plus u suffix yy. This is equal to 0. So this is equal to 0. So hence u of xy satisfies the two-dimensional Laplace equation in D. Hence u of xy is a harmonic. U of xy is a harmonic function in D. Similarly, we can show the v is harmonic. So let f of z is equal to u of xy plus iv xy be analytic function in region D. So we have to now the construction of analytic function, the method is given. Suppose that the function u of xy is given, we find v of xy as follows. Since v equal to v of xy, dv is equal to dv is equal to del v upon del x into dx plus dv dv is equal to del v upon del x into dx plus del v upon del y into dy, that is equal to minus del v minus del u upon del y into dx plus del u upon del x into dy. By CR equations we denote equation number 4, equation number 3. This is equation number 3. By the differentials we have to look into this. Then we have here m dx plus n dy, where m is equal to minus del u upon del v, del u upon del y, and n is equal to del u upon del x. Now m dx plus n dy is exact if del m upon del y is equal to del n upon del x, that is del by del y minus del u upon del y. This is equal to del upon del x into del u upon del x, or del square u upon del x square plus del square u upon del y square is equal to 0. But this is true, but this is true because u is harmonic. So f is equal to u plus v, uv is analytic. So we have to see here equation 3 is we get v of xy, then the function f is equal to u plus iv can be determined. So in this manner we have to just to solve this. Okay. Then method 2. That is Milne-Thomson method. Since z is equal to x plus iv, x plus iy, and z bar is equal to x minus iy, then x is equal to 1 upon 2 z plus z bar, and y is equal to 1 upon 2 I z minus z bar. Then f of z is equal to u of x plus u of xy plus iv of xy. This can be written as in the form f of z is equal to u of z plus z bar upon 2 and z minus z bar upon 2i plus iv z minus iv plus z bar upon 2 z minus z bar upon 2i. So since f of z is analytic, f dash of z exists for all z belongs to D, and thus we have f dash of z is equal to u suffix x xy plus iv suffix x xy. This is equal to u suffix x xy plus this is minus iv minus u suffix xy minus iu suffix y xy. By CR equation, let z is equal to z bar in the above. That is x is equal to z and y is equal to 0. Then by 4, equation 4 is equation 4. By equation 4, x equal to yes, f dash of z this is equal to ux z0 minus I u suffix y z0. So integrating, so we have f z is equal to integration of u suffix x z0 dz minus integration of here minus I into integration of u suffix y z0 dz is equal to 0. So this gives fz. This gives fz. This gives fz. So this is the Milne-Thomson method is 2. Milne-Thomson method. So again, we have some examples here. Show that u is equal to 2x minus x cube, then plus 3xy square is harmonic, and find its harmonic conjugate. Conjugate function. Hence find the analytic function f of z is equal to u plus iv. It means we have to just in solution you have to find this u suffix x is equal to 2 minus 3 x square plus 3y square. U suffix y is equal to 6xy. U suffix xx is equal to minus 6x, and u suffix y is equal to 6x. So first and second order partial derivative, first and second order partial derivatives of u are continuous. Also, u suffix xx plus v suffix yy is equal to minus 6x plus 6x is equal to 0. Hence the function is harmonic. Hence the function U is harmonic. And f of z is equal to u plus iv is analytic. The analytic. The harmonic conjugate of u is v. We determine as follows. In this manner we have to determine, again you have to take a CR equation. It means method 1, ux is equal to vy and vy is equal to minus vx. So 2 minus 3x square plus 3y square is equal to vy, that is v suffix y is equal to 2 minus 3x square plus 3y square. So integrate this, then integrating relative to y. So while integrating you will get y is equal to v is equal to 2y minus 3x square y plus y cube plus f of x. F of x is an arbitrary function of x alone. So differentiating with respect to x, this is respect to x, then vx is equal to minus 6xy plus f dash of x, then minus uy minus vy here is equal to minus u suffix y is equal to minus 6xy f dash of x by CR equation. CR equations. So that will be then again by CR equations. This is equal to then minus 6xy equal to minus 6xy plus f dash of x. F dash is equal to 0, that is f of x is equal to constant, is equal to c. So this is then integrating related to y. Yes. So this is the equation. This is equation 1. In the equation 1 gives the required harmonic conjugate function of u. Then v is equal to 2y minus 3y square minus 3x square y plus y cube plus c. So with these values of x, values of u, v, we write f of z is equal to u plus iv, which is equal to 2x minus x cube plus 3xy square plus I into 2y minus 3x square y plus y cube plus c. So Thomson method, this is, we have used the method 1. Now Milne-Thomson method. So we have f dash of x is equal to u suffix x, xy, plus I suffix I into v suffix x, xy. This is equal to u suffix x, xy, minus I u suffix y, xy, by CR equations, applying Milne-Thomson method. F dash of x is equal to u suffix x z0 minus u suffix y z0, so that is equal to f dash of z 2 minus t z square plus I into 0. This is equal to two minus 3z square. So integrating, so you will get f of z is equal to 2z minus z cube plus c. So in this manner we have to finish. Then velocity, potential, xy and stream functions xy. So in the study of two-dimensional incompressible fluid motion, we have to see the important functions. Number one, function 1, the velocity, potential, phi of xy. Number 2, the stream function, phi x of y. The velocity is the velocity of fluid particle is denoted by vector phi, that is vector q. Velocity of fluid particle, is denoted by vector q. the function phi of xy is generated from the consideration that the fluid motion is irrotation. That is curl Q is equal to 0. This equation defines phi such that Q is equal to minus gradient phi is equal to minus of phi suffix x and phi suffix y. So this is Q. Similarly, stream equation line, stream line. Equation along with the equation of continuity gives rise the function phi such that Q is equal to minus phi suffix y and phi suffix x. With these two different forms of Q, with different forms of Q result the equation phi suffix x is equal to psi suffix y and psi suffix y is equal to psi suffix minus of this minus psi suffix x. These are noting other than the Cauchy-Riemann equation for the analytic function. This will be W of z is equal to phi of xy plus I phi xy. The function W of z is called the complex potential. It is obvious that the function phi and psi are harmonic. This phi and psi are harmonic. Hence, we have, using these two conditions, the potential with a velocity phi f of x and stream function psi f of x having this harmonic and CR equations so we have again example, find the analytic function. of z who is real and imaginary. Real part is r square into cos 2 theta plus r into sin theta. So we have to just go and solve this. Okay. Here we have to f of z is equal to u of r theta plus iv r theta. The analytic and u of r theta is equal to r square into cos 2 theta plus r sin theta. ur is equal to 2r cos 2 theta plus sin theta, and u suffix theta is equal to minus r square into sin theta plus r cos theta. So then by CR equation, u suffix r is equal to 1 upon r v theta, and v suffix r is equal to minus 1 upon r u theta. We get vr, that is 2r into sin theta minus cos theta, and v theta 2r square cos theta plus r sin theta. Then find dv is equal to del v upon del r into dr plus del v upon del theta into d theta. So then integrating this, so integrating whatever will come, then f of z is equal to u plus iv. Put into that the value of u and v, then z square is equal to I theta, then z square minus iz plus ic. So that will be then the analytic function, the real part, and yes, u is a real part and v is a imaginary part. Then so in this manner we have to solve this. So analytic function is over. Analytic function is over. Analytic function is over. Here we have find the real part and imaginary part. U is a real part, V is a imaginary part. Hence analytic function is over. Analytic function is over.
Hello?